Hello everyone, welcome to Maths Easy. Today we are going to discuss about another very common A-level physics exam style question, which is to find the total resistance of a network. Now, you can see this question where you have multiple resistors connected and you need to find the total resistance. Now, uh, some of the common mistakes that people do, some people think these two resistors are in series and they think they can add 6 and 6 to get 12. You cannot do that. The reason is two resistors are in series if they have exactly the same current through it. Now that's how we know that two resistors are in series, because they have, R1, R2, and we have the same current going through all of them. Now here, whatever the current that goes through this splits up here and here. So the current in this one through this one is definitely not the same. So these two are not the same, they are not in series. Similarly, some people tend to think that this resistor here and this resistor here are in parallel. Well, the branches are sort of in a parallel orientation, but they are not really parallel. Now, why not? If you have two resistors that are connected like this, then they are parallel. Now, can you see both ends of these are connected together? Now here, this end is connected through another resistor. There is another resistor on the other side. So these two are not parallel resistors. So if you think about these things, for an example, this 12, you cannot start with these things. The only place where you can start, the easiest place where you can start this is by combining these two. Now these two resistors are truly in series. Why? Because you can see, so whatever the current that's going through this does not split up, and it's the same current that's going through this. So these two resistors are definitely in series. So 6 and 6 is 12. So now we can draw the total resistance. You can do this in your head once you get used to it, but let's draw a diagram to break it down. Now, the sum of these two resistors, the total resistance of 6 and 6 is 12. Now you can see these two resistors are in parallel. So I can easily work out the total resistance. I will do a separate video to show how to do this quickly. The answer is 6 here, but if you just do it, 1 over R total is 1 over 12 plus 1 over 12, which is 1 over R total is 2 over 12. R total is the reciprocal, 12 over 2 is 6 ohms. Now I can do another diagram and I can replace this, like both these resistors, with a 6. So since the total resistance of both these resistors is 6 ohms, that 6 ohm total is now in series with this 6 ohm. So what happens? 6 and 6 gives you 12. So let's draw the next circuit. Now the total of this 6 ohm and this 6 ohm resistors, that is 12 ohms, and now these two 12 ohm resistors are again in parallel. Now we did the same calculation here, so we know the total resistance of those two is 6 ohms. Now finally we can get the last diagram here. We have this top 6 ohm resistor here, the bottom one here, and the sum of these two is 6 again, because they are in parallel. Now the total resistance is basically the sum of the three resistors here, 6 and 6 and 6, which is 18 ohms. So this is the final answer for this question. Let me quickly explain again from the beginning on a single diagram. 6 and 6 is 12. That 12 ohms and this 12 ohm, those two are parallel. That will make 6. Now that 6 and this 6 are in series. That will be 12. That 12 and this 12 are in parallel. that is 6 ohms, that 6 ohms, this 6 ohms and this 6 ohms, the total resistance is 18 ohms for the whole circuit.